Okay, but for the finding the radius of convergence, we could also use the ratio test. I talk about that later also. Okay, it happens sometimes that we need to multiply two power series, say an xn from 0 to infinity times sigma bn x to the power of n, and from 0 to infinity. Okay, but for instance, in differential equations, we might have something like this: y times its derivative, or y times its second derivative, or its first derivative times its second derivative. Okay, here we need to multiply this. Okay, but let me give you a general formula that would be also a power series. Let's say, and this is a polynomial, say, with infinite terms, but of which degree? What is the degree of this polynomial? It is infinity. And the degree of this also is infinity. So, the degree is not the case here. Okay? So, this would be equal to another polynomial from 0 to infinity, okay? In which C0 equals A0, B0, C1 equals A1, B0 plus A0, B1, and generally Cn equals A1. Let me A1, Bn plus A2, Bn minus 1 plus dot 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 plus A n1 minus 1 B2 plus, it is A0, okay, this is A1, this is B1, okay, plus AN B0. And the pattern here is that we start by A1, A0, and Bn, and the next term would be, here we add 1 to the index of A from its previous term and subtract 1 from the index of B, as we did here. And we do this till we reach An and B0. Okay, but how about the division of two power series? Let's say this over this. Again, let me write it this way. This over Bn xn. This is also a power series, Cn xn. In order to find the coefficients of x, or the Cn's, we should multiply both sides by this, by the denominator. So this goes here, sigma Bn x to the power of n. Okay, now this is also, this according to the multiplication of two power series is also a power series which coefficients, let's say Dn xn, which is equal to An xn, okay, the sigma of that. And Dn equals to what? Equals to C1 Dn plus C0 plus Cn B0. Okay? And this is also An. And we should find the the coefficients C's, from here, starting by A1 equals C0 B1 plus C1 B0. And we know what is C0. It is A0 over B0. Okay. From here we could find C1, and A2 is another C. From that we could find more of the C coefficients. But here we got another way. We got a formula, which is this. The Cn, C0 equals A0 over B0 and Dn Cn would be 1 over B0 to the power of n plus 1 times this determinant. Okay. The first column is for the denominator's coefficients. It starts from here, A0, A1, An, okay, and the rest is for the denominator's coefficients. This is the first column for the denominator. So this is B1, this is B0, decreases, and the rest is 0. This is for this is the second column for the denominator. This is B2, B1, B0, and the rest is 0. And this is and this is Bn minus 1 B0. I told it this way, so it could be easily understood. Okay.